spend 10 minutes like doing formalities, like pretending like this is a real interview, like thank you for applying to Hackett software. I'm just gonna like skip right into it. So let's just get into the technical stuff, Keegan. So can you share your screen, like whether it's like a whiteboard thing or whether it's your text editor, or however you want to do it at first? So
I
I'll
have
just
both. Do you have a preference?
no, however you want to do it. Like you might want to pull up to draw stuff first, and then you might want to go to the code. So however you want to do it.
Okay.
So I have two questions that I want to do in sequence because one's like I think a little easier, and I think it sets up the second one better. So hopefully we get the first one done quickly, and then we'll have a lot more time for the second one.
I'm hoping that too.
But if the first one if the first one ends up being a cool challenge, that's fine too. It just turns out that that'll be the question. So it just depends on whatever. So anyway, are we doing this in JavaScript or Python? Does it?
I was hoping to do it in Python.
Okay, that's fine. So are you familiar in JavaScript though with the map function?
Yes.
So
it's a sort of a higher order function. It can go through each sequential element in an array and do something to it.
Yeah, exactly. Yeah, so I want you to implement that from scratch in Python. So make a function called map that does what it does in JavaScript, but in Python.
Okay, so I'm assuming you want me to avoid the map function in Python. That's
yeah, from scratch. Like just pretend like it doesn't exist.
Yeah. Okay. So map is a higher order function. So I'm assuming that I'm going to need to pass a function to my function to be done to my.
That is correct.
To the array or to the list.
Yes.
Okay. So is the list? I'm assuming I'm working with a list because I'm using map.
Python list, right? Yeah.
Yeah. Is the list using any specific type of data? Is it a list of strings? A list of does it have to?
No, it has specific. No, like specifically, I want you to make it general.
Okay, generally specific. Understood.
Specifically general.
Okay, so
I would have said that.
So okay, so if it's something sequential, right? So okay, so I'm going to implement map from scratch. Oh man, talk about scratch, chicken scratch. So I'm trying to get this to. All right, so map.
For those that don't know, just because people are watching, do you want to just quickly write out what it might look like if you called it and what the input might be and then what the output might be?
Yes. So what I'm thinking is I'm going to have a function, and into this function, it's going to take a list. Maybe it's the first or the second argument, and then also whatever function I want to perform on each of the elements.
That's right.
Right. So if I have, for example, if I have a list of numbers, these will be sequential. But I want to turn this into a list of the squares of all these numbers. Right. So this will be 1, this will be 4, this will be 9, 16, 25.
Exactly.
Right, so it's basically like looping through the list and doing something to that element.
Mm-hmm.
Right. So each of those will be so the function here will be something that's like def. Well, I guess I don't have to like write out exactly the definition, but it'll be like square.
Yeah.
And then a number, and it'll return num squared.
Right.
Okay. And then so the return from the map function is going to be a new list.
Yes.
It'll be so if I give it a string, will it return a list?
Just expect the input to just be a list.
Okay, so we're working with lists.
Yeah.
But the list can be.
It could be anything.
Whatever we want, because it's going to take in that other function.
Yeah, just assume that the function properly works on whatever type is in the list. And then at that point, you don't have to worry about what the function does or what the types are.
Any type.
Yeah.
Of elements, that is. Okay. So, and I'm assuming that I can just define whatever function so right now I'm thinking I'm going to implement this squared function as my first map function. Is that okay? is there a specific thing that you want me to do with it right away?
Well, no, I will, like I said, well, kind of like what we were talking earlier about how it needs to be general. It's like you shouldn't assume that you're going to be squaring. You should assume that you're going to be calling whatever function they pass in as an argument. So
right. So, but yeah,
as an example, yeah, you could like as a test input, you could do square for sure.
Okay.
That's fine. But I just want to make sure, like when you write it, don't actually in your map function don't actually square it. It's more like call whatever function they passed in.
Right, like the square will be this function here.
Yeah.
And then the map function will just implement that with each thing in the list here. So okay. So I'm going to pass the data to the map function, and it seems like I could just loop through the list and call that function with each element.
Yeah.
So right, so loop through has an H in it. The list. All right, and call.
Just because we're tight on time, I think, because I have that other question too. Don't worry about writing detailed pseudocode. If you want to just go to your text editor and just then you can write it out faster.
I love it. I'll get rid of that then. Okay, so I'm going to VS Code here. I'm going to start a new file. And I'm going to be working in Python. So I got a message. So my first thing I want to do here is set up my higher order function, my map function. So I'm gonna
you can write pseudocode here, I bet, like just because you can write it out faster.
So so I want to pass the list and the I don't know what do you want the function to the map function. Right, within there, I want to loop through the list and pass each element to the function.
Mm-hmm.
And then I want to receive the return from that and save it in a list.
Yes.
And I guess for now, I'll say to save it in a list. I could do this in the same list probably and just
you could, but I don't want you to. I want you to return a new list because that's what map does in JavaScript.
Okay.
That's what we're going.
That's great. That's great. So I'm going to catch the return from each call to inner function. And then I want to populate a new list with the results.
Yes, that looks perfect.
Which will be returned.
Right.
Cool.
That's great. That like if for what I'm looking at, if you implement that, like that should be the correct answer. So I'm already happy with this. So like the pseudocode looks good is what I'm saying.
Cool. Would you like me to implement this portion of it?
How are you like 100% confident you could do this and we could just move on to the next question?
Yeah, I think so.
Okay.
There might be some edge cases in there that I'd want to catch, like if the function.
Well, let's just do it. Just bust it out really quick. It sounds like you can probably do it quick, so let's just do it for everybody else to see.
All right, so I'm gonna call this map. I'm just gonna override the built-in function. I'm feeling bold. This is gonna take in a list. I don't want to call it list necessarily, so I'll call it elements. And then I'm going to pass in a function. All right, so then what I'm going to do here is say for element in elements. And I probably need a holder for the result. For element in elements, I want to say res equals func for that element. And then also I want to result.append res.
Excellent.
And I could probably do this in like a list comprehension, and that would work out pretty well there too.
Right. Return f of x for x in x's. Yeah, like totally. Let's just move on to the next one. You got it 100%. That was a warm up because I wanted to make sure you fully understand the map. Yeah, good job, Keegan. So now the real challenge. I want you to implement map like this for a binary tree. Instead of a list.
Okay, so it takes in a node from the binary. It takes in each node sequentially and does something to it.
Yeah, like the whole tree should be transformed. Like
to the value of it.
You're right.
And that one that you want done in place.
No, I want a new one, just like how we did it with the list.
Okay, so you want a new tree.
Yes.
And do you want this to be the tree represented as an array, as a list, or do you want it to me to build a class for it real quick?
Neither. Just how about dictionaries?
Dictionaries. So like an adjacency list, kind of, where it has a node and then the two nodes that are connected to it as the values.
Like a node will have its own value, and then it will have a left and a right because this is a binary tree.
Okay, so then sorry to move back over here. So the node in this case will be A, and then it'll have like a left, which will then be like B, and a right, which will be C.
I was thinking more like you have a property called maybe like value or something, and that's some value, like some number or string, whatever it would be. And then you'd have a property called left, and then you have a property called right, where left and right are just other trees.
Okay, so those will be other dictionaries like this for
exactly.
each node. So this placeholder right here. So what the keys? So this will be like, oh, this will actually be. So I'm just trying to determine what you want for the keys and the value. So you want
the three keys.
Here.
Yeah, the three keys are value, left, and right. Those are the three keys.
Oh, so then this would be something like node equals this.
Yes.
Okay. All right, so like node equals val. Do you want these to be strings or numbers or same
Doesn't
thing?
matter.
Sort of thing?
Same thing in that it needs to be general.
I'm gonna do this. I'm gonna do a squaring again, if that's okay.
Yeah, that's great.
For now. So the value here will start off as 1, and then left, we'll just have that be 2, and right. You said a binary tree.
Left and right both need to be trees.
Oh, okay. So so these will actually be like left equals. So, so should I set these up ahead of time like this and just do like a couple different nodes like that, or?
Yeah, you can, like, for the sake of kind of looking at what the structure is like, I think it's fine to write out some examples. So yeah, this is good. So
okay.
So let's say it's a binary tree where like the things on the left have to be less than the thing, and the thing on the right have to be bigger than the thing. So why don't you start off line 21 there? Why don't you start that off as like 10, and then the left tree's value could be 5, and the right tree's value could be 15.
Okay. And is it okay to start with just 3 nodes for now?
Yeah, so you can have the left and right be empty for the children trees.
All right, so I'll set those to none, so they point to nothing. And so left of left will be none, and left and right of left will also be none. And then down here, we want this to be left, and these should be, I suppose these should all be strings. Oops. Been writing in JavaScript too much lately.
Yeah, this looks good.
All right, so then left and right will point to this. Cool. And so just to visualize this, I'm having 10 up here, and then to the left of 10, I have, what did I say, 5? Yeah, 5. Yeah. And then over here, I've got 15.
Exactly.
Okay, cool. So interesting. All right, so I'm going to start with, so this will be my root, and that'll be the one that's passed in first. And so I guess I could do this recursively. I'm gonna have to do it one way. I'm gonna have to loop in some way, right? I'm gonna have to like call the next of whatever root element I'm on, and I'll have to check both the left and right of each subtree, right? So if this actually had other things, I'd have to check the left and right over here too.
Right. Yeah.
And that's what with trees I try to work recursively as much as I can, because that to me it just makes sense. Like, because if I can solve it for this tree, then I can solve it for all the other trees.
Yeah, I agree.
So,
I agree.
Okay, so I have this function that I want to run on each node. So I'm going to pass the node into the function instead of the into the map function. I'm going to pass the node instead of the list, and that node will have the connections to both the left and the right to call later. Do you want me to do this in any particular order? You want me to do like pre-order where it starts at the root and then does the other two, or
No, I don't care. I don't care about the order as long as the output is a new tree that has the correct structure. It's fine.
Okay. All right. So the return from this is going to have to be a new root node of the new tree, which will then have left and right as well on it.
Yes.
Okay. So I'm going to need to check the. So when I pass the node in, I'm going to square its value. I'm just going to change it because it doesn't. The value of the current node doesn't really affect the other two, because we're not like checking to see if it's greater than or less than. It already is in the right structure. So as long as I build it in the same structure, it should match the same properties. In my understanding. So if I pass this node in, I'm going to so I'm just going to square the node. Here, let me come back over here. Come down here. So write out some steps here. So I'm going to square the value of the current node. And I'm going to have to keep track of my new tree throughout this whole process. So that'll probably be, I'll probably have to return a node from the inner function, which will then be set recursively to the left and right of each node. So if I'm going to square the value of the current node and return a node with the new value. Right, now the first one will be the root, and then it'll call that recursively on the left and on the right, all the way down. So then for the root node, then I can set left equals, and then I'll recurse left.
Nice. Yeah.
And that'll return that node to the left, and then right equals recurse right. And it should, as far as I know, that should do it. I'll have to maybe work through that a little bit in the code, but did I write? So I didn't write a function for this one. I will have to write the inner function for this solution, because I'll have to return that node. So let's start with that. All right, I'll say def square node. All right, this will be my function that I'm going to pass in, and it's going to take in the root node. And
I don't think you should do it this way. I'm thinking square would just be what it was for the other map. You know, it takes in an x and then returns x times x or whatever. That would be like the function you'd pass to this.
Oh, because I'm working with dictionaries. I'm thinking working with nodes here. So you're saying.
Well, no, I mean, I don't like your function shouldn't even take in a dictionary necessarily. It's expecting 5 or it's expecting 15.
Oh, 10. Okay. So I can have the inner function literally just square the value.
Yeah, exactly.
Okay. So that'll be the same then.
Yeah.
Would you like me to write that out?
No, you don't have to.
For this? Okay. So that'll be the same. The inner function will take in a value and return that value squared.
Yeah.
And so for this outer function, def, what do I want to call this here?
You can just call it map. You can call it map again.
All right, so this will take in the root and the function. And then, so I want to call the function on the root, and the function will return that value. So I'm going to say root at the key of val equals func root val. All right, so this will square that value and reset the value of the current node.
Well, wait, just like with the array one, we were creating a new array.
Oh, right. So, okay.
So we want a new tree, right? Yeah.
That's doable. Oh, so it won't be root.val. It won't be root.val. It'll be root. And then the val will be at root, the current root. And maybe I'll even call this like new root.
Right. Yeah. Good idea.
What?
Oh, I think you just need the string.
Oh, it's geez.
Yeah, I do that.
I'm not sure why I'm forgetting that today. All right, cool. So the value is going to be the return from that function. And then what I want to do is call, right, so I'll say left is going to be map of root at the key of left. And I'm going to also pass that function. And then right will be the same. Except with right. And this is an unnecessary line. And then as far as I think this should work, right? So it'll square the value of the current node. And then for the left of that node, it'll call the map function again with the left of that node, right? So in this case, it'll be 5, right? It'll call 10. The new dictionary will have 10 as the value. Right, val is going to be 10 because that'll be, or sorry, it'll be 100, right? Because that's the return value from that function. And then it'll call left, and it's going to run the same exact thing on left, except here we have nothing. So on that one, we're going to have left. That one's going to be a new dictionary, right, where the val is 25, and then left and right are none. Because none squared is none. If I can even run a squared function on none, I'd probably have to catch that and be like, if the value is none, return none. Right. So in this case, the value would be 25. This would be none, and none, and then right would be the same, except with 15. So whatever 15 squared is.
Yeah.
I'm not that good at math right now.
Same here. Oh, that looks good.
And I think this should do it. And then I'll just return. I mean, I don't even have to. I could just return that. And I think that's good. I mean, I would definitely.
Well, so let's get back to that whole thing about what if the value is none.
Okay.
Like what,
So
I think that's a relevant thing to be considering right now.
Probably do something like that. Well, it wouldn't have to be. It would have to still be a new dictionary, wouldn't it?
Well, no, you shouldn't be so concerned about if root val is none. Just assume val is whatever it needs to be for your function to work. But it's more like
okay, hang on. So what was I saying?
Like I'm foreseeing a potential problem is what I'm trying to say. Like maybe if you actually walk through an example, like step by step, you'll see there's going to be a problem.
Okay.
Maybe just pretend to be the interpreter and actually execute your code on an example line by line and just like see what's going to happen.
Sure. So I'm going to do that over here visually, if that's okay. Delete this. Okay, so I'm going to pass in root. And root right now has a value of 10. And left is this dictionary with the value of 5. None.
Mm-hmm.
Right, and right will be the same, except it'll be 15. These are the worst curly brackets I've ever drawn. Whatever, they're gonna be bad. That's fine. So this will be 15 and then none, and then none. All right, so the problem I was seeing before is with these nuns, right? So when none comes into here, it won't be able to square that value.
I agree the problem is with the nuns, but don't worry about like your square function not working. Anyway, yeah, just keep walking it through.
Oh, I can't use keys on none type. So if it passes in a blank dictionary, it won't even be able to find the key of value because it doesn't have that. So that'll cause a key error at least. So let's walk through this. Let's walk through this, right? So it takes in 10. I wish I could put these side by side. And it's going to call the square function on that, which will give me 100 for the value. And then it'll call left, the same thing on left.
So let's dive into that call.
Okay. So left, right, the value itself should come out fine because I have a value there. So the first one should be 20, val will be 25. Mm-hmm. And then when it calls recursively again, it'll pass none to that function for the root.
5 minutes.
Thank you, June. And so that's what I was talking about there with the key error, right? So when I try to do at the key of val, it won't find that.
Yeah.
So yep. I mean, could I not avoid that by just returning none instead of that new dictionary?
I think you're right. Let me see exactly what you mean by that, but I think that's right. So
like if I say if root is none, return root.
Yeah.
And then and otherwise return this new dictionary, which will then be saved recursively to the left or right property of whichever node I'm working on.
Right. Yes, this looks good. Yeah, no, I think this is good. This is about what I have. I did it in JavaScript, but it looks like almost identical to what you just wrote. So I think you're good. You'll be hearing from my people.
and I like passing a blank function in here too. Like I could probably put some checking in there, like a try and accept. And if that didn't have a function within it, I could return an exception or something like that to make it a little bit more
but
solid. Yeah, but otherwise it would say like none type is not callable if I didn't pass something for that, or something like that.
Yeah, for sure. I mean, the JavaScript map function, which we were kind of modeling this after, it doesn't necessarily check things about your function. It just tries calling it and just sees what happens, right?
Cool.
So I think this is what I was expecting, or this is good.
Nice.
Yeah. So I mean, we don't really have time for any follow-ups. I didn't really have any follow-ups prepared, so I think we just finished like perfectly on time. I think we should all give Keegan a round of applause because you totally killed it, dude.
Yeah, recursion's awesome.
Good job, Keegan.
Thank you.
And by the way, this is similar to the interview question we ask at my company that I work for. So this is realistic. It's a very realistic kind of interview question. Like you would pass that interview, in my opinion. So yeah, good job, dude. Seriously.
I appreciate that. This was a fun challenge. I've been practicing a lot with recursion, and I really like it. I think it's really cool. It's unfortunate when you reach that call stack limit and you can't really use recursion. But
yeah, that's true. Some languages they have something called tail recursion where they don't create a new stack frame. They immediately can reuse the current stack frame on recursive calls, so then you don't run into that. Yeah, most functional languages do it that way.
Python does not do that way though.
No, yeah, the stack blows up really quickly in Python, I found.
It does. Yeah, it's unfortunate. Cool. Yeah, that was a really fun question. Is there anything that I might have been able to improve on in terms of my preparation or in other questions that I guess I forgot to ask about if the root was blank. But that was already it was kind of baked into the question though, because I was inevitably would have reached a blank node anyway.
I mean, the one thing is with tree problems, you always are going to have that what's called the base case of your recursion, where you check if the thing is like the base case, right? If like the empty node or like the none case or like whatever it would be, or even a recursive algorithm that's just working on numbers like a Fibonacci sequence recursively, it has a base case too. They would be like the lowest numbers in the sequence. So recursion always has base cases. So I always just start with that. Like as soon as I open up the function, the first thing I do is like, and a base case is always an if statement. It's always like if base case, right? So That's what you could just do immediately. You just write the words if, and there's going to be a base case coming, and you just have to think what is the base case. With trees, it's usually like an empty node, basically.
Yeah.
So, but I mean, you did figure that out. It's not like I had to necessarily tell you, like, so I actually don't really hold that against you. You just kind of forgot about the base case. I'm sure when you practice trees, you probably, were aware of the if statement at the beginning that checks for an empty node, but you just forgot to write it. But then you figured it out and wrote it in. So like, I'm happy with it.
Cool.
In terms of like other stuff, I mean, honestly, dude, I was trying to think about this, like, as we were going, like what kind of feedback I can give you, but like, you just did a really good job. Like, I don't really have much to say. Does anybody else have feedback? I was paying attention to the code and stuff. Was anybody else maybe just paying more attention to like other things? Maybe did someone notice something that Keegan could have done better?
You did a great job.
I agree. Seriously, like I'm not just being nice. Like I wanted to be helpful and have like a big list of stuff, but I don't. You just did a good job.
Thank you.
Yeah.
I appreciate that. Yeah. And for all of you who are practicing recursion too, this is exactly the way to do it, is to figure out that base case first. And I'm not sure why I overlooked that originally, because usually when I work with recursion, that's the first thing I think about. Because that's the simplest case, right? That's like, and in fact, looking at a tree like this is the simplest case. I guess like a single node would be, right? So if this had no children, it would just return this node, which would be just its own dictionary, right? But it would have been affected, right? It would have had 100 as the value instead. But since I have a nodes attached to it, I had to check those recursively, right? And so this would continue on. So if I had nodes here, right, it would say, okay, I have a left node here, so I'm going to check that, and then it would square this value and say, oh, I have a left node, I'm going to check that, and then once it figured this one out, like if this was 4, it'd be 16 or something, which probably wouldn't fit into the pattern of my numbers, but then it would check left here, and if that was blank, it would check right here. If that was blank, it would return back to this node.
Right. Eventually, you'll hit
and then check right.
something that's empty, right?
All right, and then it checks right, and then we get 2 X's there, and then once it returns back to 25 again, then it goes back up to 10, and then checks the right. Right. So so the way I laid it out, and it could have done this in any order. The way I laid it out is to check all the lefts first until I hit a none node. And then it returns to the most recent node and checks the right. And then it returns to the node before that and checks the right, and goes through that whole tree.
Right. It's called depth first, by the way. If anyone's curious, this is called depth first as opposed to breadth first, which is where you kind of do all the children and then do all of their children and then do all of their children. This goes deep on one branch first. Yeah. So yeah, you guys should learn that, by the way, like learn depth first, breadth first, and kind of practice both. Anyway, other things Keegan did well that I want to highlight is the talking aloud as he went is super important. That's just what people are looking for too, is the communication. So basically every time Keegan was about to do something, he would say what he's about to do, and then he would do it and then say it as he's doing it. And that's really good. You got to be constantly communicating your ideas, which also helps kind of validate your plans, because if the interviewer is like, wait, that you're going to go down a wrong path, I don't want to waste much time going down a dead end, so let's not do it that way. So by always kind of saying what you're about to do, and just kind of, there's body language things, and you can just kind of see if you're going down the right path or not, and then you just kind of be like sussing out what they want by just communicating a lot. So basically the idea is just talk a lot is basically the idea. It can be hard when you don't know what to do at all and you're feeling stumped. It can be hard to just be talking because you need to just sit there and think. So sometimes, like when I'm in an interview and I have to do that, I'll just tell them like, okay, I just need to think about this for a second. And then once I kind of have my plan together, I'll start talking and trying to talk about the plan. Yeah, in general, so that was really good. I think I can't give criticism. I'll just think about the things you did well and just talk about that.
So I have a quick question. So it's like totally okay to just continue to ask questions about what you're supposed to do, because in most job interviews, if you ask the question about what you're supposed to do, like you're not going to get the job. You know what I mean? Like you're automatically supposed to know what to do when they give you the question. Okay.
No. Yeah, you ask clarifying questions. In my tech interview talk from last week, where I had like a little slideshow. I think we recorded it. I talk about that, like clarifying questions is like the first thing you do, where you just try to figure out what they actually even want you to do. And one of the things you can do is kind of like write an example input and then be like, is this what you expect the output to be? Like if I input this into the function, is this what it should output? And you might be wrong. They'll be like, no, I was thinking more like this. And then you go, oh, okay, so like this. And then once you have an example that you and the interviewer both agree on, then you're on the same page. Then kind of move on to the next step. And then as you're going, you can ask clarifying questions too, like, oh, should I handle this error? Like this could be an error here. Like, should I handle that, or should I just assume it's good? And they might be like, oh yeah, you can just assume it's fine. Anyway, so yeah, always be asking questions. And so talking aloud, asking questions the whole time is a good thing. So yeah, don't just assume you know what they want and start coding, because you might be wrong and then you just went down the wrong path and wasted a bunch of time. Also, they're gonna think of that as a negative that you didn't ask questions. Like it's kind of looks like a good thing to be trying to figure it out.
Okay, cool.
Yeah, and this problem too could have looked differently if you wanted it in a specific order of the nodes. So I asked, like, do you want it in, like I wrote them here, do you want them in pre-order, in order, or post-order? And these are just different ways of visiting these nodes, right? So if I'm going pre-order, it visits the actual root node and then the left and then the right. And then if I'm going in order, it goes left, root, right. And and that can really affect the output of your program too, depending on the task. So
right. So yeah, exactly. So that always ask things like that. And I want to also highlight that it's not like Keegan has never seen a tree problem before and just figured out how to do it right now. He practiced these kinds of problems, and that's what I was talking about last week when I said in my slideshow, when I said, you need to know these kind of data structures: trees, stacks, queues, linked lists, arrays, graphs. There's like some handful of things I listed out, and I said just read Cracking the Coding Interview or whatever other resources to help you learn those things. So Keegan's been practicing, right? So I just want you guys to know too, like if you saw this problem and you thought, oh, I would never be able to do that, I had no idea how to do that. Well, it's just because you haven't probably spent enough time practicing trees specifically. So trees is like one of those categories you need to practice in. So I just wanted to mention that because I don't want people to think like, oh, Keegan must just be like a high IQ genius or something, right? I mean, I'm sure he is, but it's also it's also just that he practiced this, right? Keegan, didn't you spend time specifically on trees?
I did, and I spent a lot of time with trees. I spent a lot of time with linked lists, and it really broadened the depth of my knowledge on these things. Like, it just writing functions that do these three, like traversing the tree in these three ways, doing it recursively, because I could have also it taught me so much about recursion.
Yeah.
And I was like sort of familiar with recursion before, but just practicing with trees like that taught me so much about it. And I could have probably done this iteratively, where I set up a queue and picked a node and did that, and then moved on to the next nodes in the queue. But I chose to do it recursively because trees are often done that way, and I think it's really nice and clean this way. But,
yeah, definitely.
But I never 6 months ago this would have blown my mind. Like I would have been like, what?
Right. So I want to highlight that too, guys. Like you really do need to practice these, because if you think like you just write a lot of code so you'll be fine, it's like, no, like, because these kind of questions are different than like if you write a lot of Django apps or whatever, and you're practicing that, like these kind of questions it's not the same. It's a different kind of coding with this, like data structure stuff. So you have to practice it specifically.
And the data structures are like to really pound in that point. Like, the data structures are, in my opinion, more important than the algorithms.
Yes.
Because if you won't even understand, you won't even be able to comprehend the algorithm without a good working knowledge of the data structure.
Yeah, I agree. Yeah, don't just try to memorize like algorithms. Learn the data structures, and then the algorithms will come more naturally after that, because the data structure is kind of, I don't know. It's just the structure is so, the algorithms kind of fall out of the structure in a way, if that makes sense. If you try to learn the algorithms first, it's going to be way harder. So that's a good insight, Keegan. Yeah, data structure is more important than algorithms.
Yeah, and if I didn't know how to traverse a tree like this, it would have been a lot harder to run a function on each of the nodes. Like maybe impossible, because that's the first required step is to be able to traverse the tree.
And so I asked Keegan ahead of time, have you been practicing? I basically was trying to see if you've been practicing trees. So I asked him what he's been practicing, I think, and I figured out he's been practicing data structures. So I knew that he would be able to handle this question. But anyway, when you go in an interview, they're not going to know what you've been practicing. So like they might just ask you this, and you might have never practiced it, and that's when it's going to be really hard, and you're probably not going to figure it out. So you need to be able to you'll have more confidence if you just spend some time grinding out some of these problems, really learning the data structures. And I mean, I think Keegan's showing you like, you can learn this stuff on your own in a somewhat short amount of time. So,
and
right, you've been doing this for like a month now. You said you've been doing the data structure.
Yeah. Pretty intensely for about a month. I like practicing regularly every day-ish, maybe every other day, trying to either read about a data structure or code some algorithm with the data structure. I'll post some links to the websites I've been using. I've been using this website called Techie Delight, which is fantastic. It goes through all these different things. It has Python and other language examples of the algorithms that they implement. It talks about time complexity, and it talks about what the algorithm's doing. Right, so it gives you a chance to like come up with the algorithm yourself by just describing it, and then it also has the answer for you and the time complexity, and that has helped me so much because I can get, and then because that's my biggest problem with a lot of these coding websites, that you either have to have a subscription to see the solution, or you have to solve the problem first in order to see the solution, and a lot of the times the solution just like doesn't make any sense once you get there. And so I'll post my resources for what I've used to learn too. And then also Cracking the Code Interview was a huge help. That book is amazing. And also the book Grokking Algorithms was another really good one for me. So you can find all those like as PDFs, I think. I have at least. But yeah, that's data structures are the biggest piece here. And just knowing how to traverse a tree was the thing. And so another tricky thing is that a tree can be represented in multiple ways. Like I had to ask, like, is the tree going to be represented as a list? Is it going to be represented as nodes? Because I could actually make a class that has a left and a right property. But here it was represented as a dictionary. And I've actually never really worked with a tree as a dictionary or as dictionaries too much. So I kind of had to like take from what I already knew about trees and apply it to a dictionary. And even just knowing about dictionaries, that's a data structure in itself.
Another thing I want to say is like I noticed that too when I asked you to do it that way. There's like a moment and I could tell like, oh, you haven't done it this way before, but you weren't like pushy about doing it the way you know how to do it. You were just like, okay, like cool, let's do it with dictionaries. You know what I mean? And that was awesome. Because you could have been like, well, I know how to do it with classes, so that's how I want to do it. but you're like, okay. I'll do it with dictionaries. That's cool. And you were just positive about it. And then you because you had practiced it enough with the other ways that you were able to figure out how to do a dictionary. So
yeah, it took me a try. It took me a try or two, but I got it.
Yeah. And that also more clarifying questions, right? He was trying to figure out what was the exact format this should be represented in. Because that's the thing. The interviewer won't always just tell you exactly what they want. They're kind of wanting you to like extract that from them by asking questions. And partly because that's a real world skill on the job where like you'll be tasked with things that aren't extremely specific, and you kind of have to do more research and ask more questions, especially when you're working with non-technical people, because a lot of times we're building software for people who aren't technical, and they'll tell us what they want, but they didn't really spell out all the little details of how it should work, so you have to try to figure that out. And so that's always a good sign when someone's asking lots of clarifying questions. Well, yeah, I don't know. Any other questions or comments?
When can I start?
Yeah, we'll get back to you.
I have a question, and I'm not as familiar with technical interviews, but what happens if you get into an interview situation and you just don't know how to respond and you're sweating bullets?
Yeah, that's rough.
How do you work through that moment? Any tips for that? Either one
There's
of you?
no way around it. Like that's going to be rough, but obviously just try your best to be positive. Just take an opportunity to ask more clarifying questions. Also, you can, if you have to, it's admit that you need some help getting started and the interviewer might help you. Look, if you really just don't know how to do it, like you're probably not going to get that job, but you can make the best of it. And it's possible you can learn something from your interviewer if you work through the problem together. If your interviewer is like a cool person, they'll work through it with you, and you probably won't get the offer, but like you'll have learned something, and it won't be such a horrible experience because it could be fun potentially. I mean, there's no way around the fact that that's going to feel stressful in that moment, and it's going to be rough. I've never had a situation where just like, the entire time I just had nothing and I just was just standing there drawing blanks. But I've had moments that start to like, and it gets stressful when you're like, you don't want to be wasting time. So you're like, and I'm just like, okay, I just need to like think about this for a second. Cause I want to be talking cause I know that's good. But if I just need to sit there and think, I'll just tell them that I need to think about it. And then I'll just try my best to ask questions that help give me hints in some way.
Yeah, just because you don't know about the specific thing that they're talking about doesn't mean you know nothing. So maybe what they're talking about is parallel to something you do know really well, and you just don't know it yet. So
and then another thing is like at some point you could just start writing code if like, and because I don't know about you guys, but for me at least, sometimes like if I don't know what to do, but I just start writing code, like things just start coming together. Or at least like I start seeing things that I wasn't seeing before I had any code on there. Once you get some code down, then you're like, it kind of helps you. Sometimes it doesn't work out. You go down a wrong path, but like, if you have to just be like, okay, let me just start writing this out and see where this takes me. And then you'll run into some dead ends, but then you'll realize that and you'll talk about that and then you'll try a different direction. And then,
and honestly too, like I got me one of these whiteboards here, and for my preparation for this, I would literally pull up a problem and talk to myself with my whiteboard and work through it. Be like, okay, well, if I have this and I do this, and then it could look like this. And then through that, I might come up with the algorithm or not.
But also, I want to reiterate. Wait, hold on. I want to reiterate something really quickly about that question that June just asked. It's also just that's avoidable if you learn the things that I talked about last week. That category was like 6 categories or whatever that they talk about in cracking the coding interview, and all those fundamental data structures and those different types of problems. If you just practice those, because you basically know that you're going to ask something like that most of the time. So if you just practice those, you won't be like just having no idea how to do it. So that's really the best way to answer that question, June, is just do the thing that we've been telling you to do, like read Cracking the Code interview, practice these questions every day, mock interviews with your friends. Then you will know what to ask, and you will know because you'll have seen trees before. Even if you don't know the problem, like I could have asked Keegan this tree problem, and maybe he would have never seen the map function before, but he kind of knows trees, so that would have been an extra challenge if he didn't know what map was. But because he's done trees, he at least kind of knows how to approach it. So that's the thing, is like if you know the fundamental data structures, you'll know at least how to get started, what kind of questions to ask, even if you don't actually know what they're asking you in a way. So just avoid that problem the best you can by just doing what you know you should be doing. Anyway, John, what were you about to ask?
So I had a question from the beginning, and Keegan, I know I got here a few minutes late. I think I came in at about 11:35 when you started to talk about the whiteboard, the sketchboard on screen. But for both of you, for Keegan, how often do you use that? How have you found that useful? And then for Evan, like, did you think that was useful? Could he have done better? Is it possible to use like a handwritten paper, or is that silly for on-screen interview? So from both of you, please.
Yeah, well, I've sorry, Keegan.
No, you go ahead. Go first.
Okay, so I've never seen the paper thing, but a lot of my interviews were before the COVID thing happened, so a lot of them were in person. But usually when you do like a video call interview, a lot of times they'll have you write stuff out in Google Docs, and like you'll just be writing code in Google Docs, but you can also be writing notes and writing like your plan and your pseudocode. But like in person, I would always use the whiteboard because a lot of times you're doing it on a whiteboard anyway. You're writing your code on a whiteboard. So then right next to your code, you could also just be drawing diagrams. And I think for like especially for like the tree problem, like, drawing out a picture of a tree, I mean, that's like obviously super helpful to do that and kind of show the examples. And yeah, I would definitely recommend that. The whiteboard is one thing that's really nice too, is like you can write little things like right next to code that you write or like draw arrows in a way that you can't do in your text editor. Like you can't really just draw an arrow from one line to like a picture. Because if you have like a diagram and then you're writing your code and then you want to like draw an arrow from your code to your diagram, like on that line, like that's like so easy to do when you're just doing everything on the whiteboard. So it is kind of rough when you're switching back and forth, like your diagram's over here and then your code's here. But I still think it's helpful. But yeah, definitely practice that kind of skill. It's just another skill to practice. Like if you're not used to writing code on a whiteboard, you should practice it, and it'll really help you in an interview, especially if they make you do it in a Google Doc. That'll be something that you'll want to have already practiced. But anyway, yeah, Keegan, did you find it like actually, aside just that interviews like to see it, did you find that actually like helped you?
I swear by whiteboards and drawing stuff out. It has been the single most helpful thing in learning coding for me ever. So I highly recommend it. I've been doing it since I was 16 or something. When I first started learning code, I was drawing on a whiteboard to figure stuff out. I took a long break in between, but I'm back to it now, and it's quintessential for me. I'm such a visual person that I cannot fathom these recursive, these different things. I can't do it without the help of a visual aid.
Yeah, that's really
So I either have to use my debugger and like go through line by line, or I have to draw it out and conceptualize it first. Plus, it helps me avoid so many pitfalls. Like if I draw it out first, there's a much higher likelihood of me typing that code in and it just working, because I've already worked through it in my mind logically on the board. You know, like I feel like personally, I feel like I fall back on print statements too much, right? And using those as my primary debugging method. But a lot of it is in the planning. Like a lot of those things you can kind of suss out in the planning stages of your code before you even implement any of it. And that takes practice. I've been doing that for a long time. But you can get those little Wacom drawing tablets. They're like maybe $30 to $50. I had a little like 3x5 one that was really small that I used for a long time, and they just plug in USB. They have a little pen. This one's actually on my laptop screen. It is touch screen, so I can do it that way, which has been really useful. But the whiteboard is still my favorite. Like if I could have done this on a whiteboard, I would have preferred to do it that way, because I think it's just a really nice way to do it. But yeah, I mean, I can't swear by it. I can't speak highly enough of it, especially when it comes to things like recursion, which are a little bit harder to conceptualize. The visual really helped me to get through with that stuff. Plus, like if you're working with trees and stuff, you might need to move nodes around. You might need to do different stuff, and so like you can actually like erase the line in between a node on the whiteboard and point it somewhere else.
Yeah, like with linked list problems, I really like just like erasing the line and drawing it to a different node or something. Like that's really useful.
Yeah, and it's extreme because not only is it a good visual, but that's actually how it's working.
Right.
With a linked list, like it's literally pointing to a different area, and so you can like change that pointer visually. And because it's like that was one thing I really struggled with trees and stuff, and learning this is that you cannot print it out. Right, you can't print. It would take some really fancy code to print out a tree in the terminal. That'd be
a good interview question.
Yeah, that'd be awesome. That'd be an awesome one for honestly. And I've thought about it. I'm like, I don't even know how I would go about starting that. So in terms of that kind of stuff, the whiteboard and the visuals have been immensely beneficial. And then I'll post it in the Slack too. But that Visualgo website has visualizations of all the different data structures and different sorting algorithms, different algorithms you can do with this stuff. Because there's a lot of similarities too. Like trees are very similar to linked lists, very similar to graphs, very similar to all these other heaps, all these other structures. Like a heap is a tree, but structured in a certain way.
And a linked list is a tree, but it's just with one child.
Exactly.
Each node is one child.
And so there are definite parallels between these data structures too, which can be beneficial. So when you learn about linked lists, you're also learning about trees.
Yeah, that's true. Yeah, in general, like learning all that stuff, like when I listed all that stuff, it might sound like a ton to learn, but it's really like it all helps. Like everything you learn helps you learn the other things. So it's like it all is like a big web that, in a way, it makes it easier.
Well, and having this problem presented as dictionaries for the tree nodes. Like I said, I had with that, but I knew enough about how trees worked to kind of, reason my way through it. And so these things can be like, and I've seen graphs expressed with dictionaries more like as adjacency lists more than I've seen trees with dictionaries like that. But they're so parallel, they're so similar that I was able to put it together like that. But yeah, I mean, I don't want anyone thinking that it's simple. I've definitely had some serious like emotional trials during this process, and I'm sure those aren't over. But
so here's the thing, guys. Like I know like last week I said it, and before someone else has said it, and now today we're saying it again. Like you all know what you need to do, okay? Like get a whiteboard and get cracking the coding interview and practice these problems. Like if you don't do that, but then you keep showing up to these things and what are you doing? Like, just practice. Like we're telling you exactly what you need to do. All right. I just know that someone here is not doing it. Like someone here, I don't know who, I just know probably all of you, to be honest, like aren't actually like who's here, like who has a whiteboard and who has cracking the coding interview. Like, have you done the things? Have you gotten the resources that you need? Who's still waiting to do that?
I didn't know until today.
Okay, Ebony, you're off the hook because
Yeah.
you weren't there last week. But last week I talked about this.
And,
So-
you can find cracking the code interview as a PDF too. All the code examples are in like Java or C++ or something, but they're identical.
And if you don't have a whiteboard, you can use a piece of paper also. Like, you know, you can practice by just writing. But yeah, guys, like it's just like you got to do this work. There's no way around it. But it's not that bad. It's like not as like passing the boot camp was a lot of work, and you all did that. So just follow through, do these things that we're recommending. I don't know. I just
and start basic. Like start by setting up a linked list. Just
like
build
1
a-
month from now, if I give another talk like this, like Dustin, John, let me like write all these names down. Charlie, Ebony, Jasmine, Joe. If you guys haven't practiced the stuff that we're like giving you the solution. We're like, this is what you need to know. And if you don't do it, I'm gonna be disappointed. All right.
And
Now,
I've asked you
that's
about
it.
algo questions. You know I'm practicing.
Yeah, I have gotten questions from Dustin. So, and that said, so you can ask me, and I'm sure anyone else, pretty much, like everyone in this community wants to help. So it's not like I'm saying you have to go do this on your own. I'm just saying just start doing it. So ask me for help, ask Keegan for help, ask
Certainly.
anyone. And just post in the alumni hacker space, or in the career services. I don't know. Just post on Slack. Somebody will help you. And even if you want like a video call, like schedule a video call with me or Keegan or whoever, and we can help you more one-on-one. I've done that before with people. People usually don't ask me to. That's why I don't do it. It's not like I don't want to. I don't have any time or something. It's like no one ever asked me. I think like Ebony is like the only person that's ever asked me to do that. Do you remember that, Ebony? We like did some drills on some things together.
Yes, thank you. I always hear your voice in the back of my head whenever I'm doing anything. So
Cool. So yeah,
That's
just
the
like
indication of a powerful hour together.
yeah, we drilled it hard. Sometimes repetition is really important, so it's just like practicing it, you know. So anyway, you're not on your own, is what I'm saying. Like, but it is like we can't make you practice it at this point. Like you've graduated, you're like you're responsible, but you're not on your own. Like we will help you, but like I just wish sometimes I could just like make people practice because I know exactly what they need to do, and then I don't see them doing it. So it's like, what's going on?
And that's a classic thing too. Like we could teach you how to write these algorithms, but you're never going to learn them until you actually do it.
Yeah.
Like even seeing me do this, well, if you were tasked with the same thing, you wouldn't be able, you might not be able to do it the same way I did, and
Right.
you won't be able to do it at all until you actually do it. That's another thing. I started off this whole process by watching a lot of videos just to do research, and then I was like, yeah, okay, I understand. Breadth first search, and then I would go to do it, and I'd be like, wait a minute, actually, I don't. I understand
Yeah,
the concept
exactly.
of breadth first search, but to write the actual code is totally different. And then time complexities and all that kind of stuff is additional as well to this, which I think this one is O-Ven because it has to visit every node.
That's right. Good job.
I
Yeah.
want to make one other comment too, and this is more than the tech interview, is now everything is on by video. So it's really important to kind of check if you're going into an interview to make sure you're, well lit, your background, you come across well, you speak well, clearly, your speakers, microphone, all of that's working as well. And of course, Keegan, you presented very well. So good background, good lighting, all of that stuff. So that's just another, it's all in the details as well. And,
Yeah.
and another question too is, do you have to have questions at the end of a tech interview? Should you be prepared with additional questions like a regular interview or not?
Yeah, well, it depends on like how they do it. So like a lot of companies schedule multiple interviews, and like after the tech interview, there would be like another interview that would be maybe more behavioral or whatever. And then And then anyway, so you might have a sequence of interviews. So then it's like, it might be that one of those are like where more of that time would be, where you're asking them questions. But I do find that like almost every interview, they do say like, okay, do you have any questions for me? It's just that the tech ones usually run late because, you're trying to like finish this problem. So usually there's like hardly any time for that. You probably would have already had a time for some of that earlier, and then you'll probably have another time for that later. So yeah, I wouldn't worry too much about questions during the tech interview.
Okay, that's it. I think I'm gonna stop here. So hold on just a moment.